Right, so we've gone through the method that we use to solving Runge-Kutta, or the method that we go by when solving ordinary differential equation using the Runge-Kutta method. And we've gotten to know that we're having the second order, the third order, and the fourth order. In this question, we are asked to find, using Runge-Kutta method, of second order, precisely second order. So it means that we have to go by the algorithm of second order. So we have to find y of 2.25. So it means that we want the reflection. If x is 2.25, what will be our y? That is what we are going to look for. And we are having the ordinary differential equation, dy dx equals x plus y, all of x. This is our function. So the x and y value that we get, we input it in our function. And this is our initial condition. This is for x naught and y naught. Very good. So let's start solving it. So for Runge-Kutta, or using the second order method, we know that y I plus 1 equals y I plus 1 on 2 k1 plus k2. We know our s naught, so s naught equals 2, y naught equals 2. Very good. What about k1? We don't know k1, so we find k1, and we know our h. We know our h to be 2.25. That is our h. So you'll be taking our h to be 0.25. Our h is 0.25. So this is our h. Very good. So our h is 0.25. Now, put, and the iteration start from 0, that is I start from 0, 1, 2, 3, up to infinity. So now, let's put I equals 0. If I is 0, we know definitely that here will be y1. So if I is 0, y1 equals, here will be y naught. So y naught plus 1 on 2 multiplying k1 plus k2. Very good. So now, how do we find our k1? We know our y naught. Our y naught to be 2. So for y naught, we know it already. But we don't know how to find. We don't know k1 and k2. So we find k1. That is h multiplying the function si, y, I. We know our h to be 0.25. So k1 will give us 0.25. Our function, let's write our function. And I is 0. We said that I is to be 0. Put I equals 0. So here will be si. And sorry, here will be x0 and y0 because I is 0. So we know our x naught. X naught is 2 and y naught is 2. So the function will be 2, 2. Very good. So this is the main function. So we have to substitute the value of x to be 2, the value of y to be 2. So our x plus y on x, which will give us 2 plus 2 on 2, and we know that is 2. Very good. Now, we know our function to be 2. Here is 2. So now, our k1 is equal to 0.25 multiplying 2. So k1 is giving us, so let's punch it on our calculator. 0.25 times 2. And the answer is 0.5. So we're having 0.5. Very good. So K2. Now K2 is h of f si plus h, comma yi plus h. Very well. So this is our K2. So now we know our xi, we know our So here now, here becomes S naught, here also become Y naught. So our H is 0.5, so 0.5 F. We know our F to the function. Here is 2, S naught, that is 2 plus 0. 0.5, 2 plus 0.5, comma 2 plus 0.5. H is 0.5. Sorry. Our H is 0.25. So 0.25. 0.25. Very good. So now we are to add this function. So we are now getting 0.25, a function 2 plus 2.5, comma 2 plus 2.5. So this is our x value and this is y. So we just substitute it as we did here. So let's say 2.25 plus 2.25 all on 2.25. Just pick your calculator and you punch in your answer, and you know that the answer is 2. So we are getting to just, so the function is 2. So now 0.25 multiplying 2, here now we've gotten 2. So this is just the function. So the function, I just want you to understand it. So that is the function. You just impute these values into the function. So now multiplying 2. So 0.25 multiplying 2, the answer is, we are getting 0.25 by 2. You're getting 0.5. You're getting 0.5. Very good. Let's take this one again. 2.25 plus 2.25 all on 2.25. Very good. So you are getting 0.5 here. 0.5. Very good. Now we know our K2, we know our K1. So K2 is 0.5, K1 is 0.5. So what we are going to do is that we are going to substitute it in this value, in this algorithm over here. So let's substitute. Let's make the substitution over here. So y1 equals I naught give us 2. That is 2. I naught give us 2. So 2 plus 1 over 2. And we had K1 to be 0.5. 0.5 plus 0.5. So 2 plus 1 on 2. 1 on 2. So let's calculate the 0.5. 0.5 plus 0.5. 0.5 plus 0.5. And 1. So 2 plus half. So our result is 2.5. So this will be the reflection of 2.25. This will be that reflection. Thank you.